Hi, welcome to the tutorial for Conda environments for basic Unix as part of the BVCN. Today we're going to walk through the demonstration that has been created for us in the Happy Valley Bioinformatics tutorial setup to discuss what Conda is, why we use it, and how to use it properly. And so just to get started, so Conda is a system that allows us to handle installing tools easily. If anybody has been out there for a while and has played around with installing bioinformatic tools, you might be aware that some of them are pretty impossible to get installed correctly. They require a very large number of prerequisite tools that have to be present there. You have to get them set up in the right environment, databases in one spot, and paths set in a particular way to make sure that everything's being called correctly. It can be very cumbersome, and one of the many ways that people start working with bioinformatics and then become discouraged that they can't achieve what they want to do in a time without learning a whole bunch of new skills. Conda helps to reduce that particular load of expectation for people to have coming in new to this area. And one of the things that I like to think about is I've been doing this for 10 years, and for a very long time I was resistant to Conda, being like, I know how to install programs, I can get things to work, why would I want a tool like this? But Conda actually provides something that a lot of other instances don't, and that's this control of your environment in a way that allows you to have specific setups for specific bioinformatic tools that you're working with so that they continue to work in a fashion that's, one, consistent, two, easy to upgrade and reinstall if necessary, and then three, which is really impressive, is that once you have an environment for which you're comfortable with, and it's not something we'll talk about in this tutorial, but you can actually directly export what that environment looks like so that other people can set up with the same system and the same working environment that you are working in to make it work for reproducibility and things of that nature. And so the big couple of the big selling points of Conda are kind of laid out here by the author of the tutorial, who's Dr. Michael Lee at NASA. And so it allows us to create these separate environments that then allow us to install programs that don't conflict with each other. And that might sound somewhat trivial, but especially I think as bioinformatics as a field continues to expand, there always seems to be this disconnect between tools that were created maybe around 2015 and before, and tools being created now, with the tools being created now designed to fit into this mindset of getting in packages, making them open and allowing people to use them readily. And earlier tools tend to fall under a system that, you might click a link and end up at a website that doesn't exist anymore. You might come across something that is broken with the current system that's set up. And so those types of problems might preclude you from doing this. So that kind of divide of old versus new, Conda is one of those things where if somebody were to take the time on one of those old programs to make it Conda available, you could kind of somewhat preserve that going forward. And I think you'll see that as tools are being developed and they're being packaged in Conda, you'll be able to more reliably get tools that 5 years from now are the cutting edge now, but in 5 years from now might be a little older, but still maybe worth revisiting and having access to. So what we're going to do, the overall tutorial is going to be fairly short, but what we're going to do is we're going to start up our binder, which you can do by clicking this button right here, which will bring up our binder environment that looks like this. And then under other, we're going to click terminal to start a terminal environment for us to work in. And so that's what that's going to look like. And so what we're going to do is talk about how Conda is set up and what its initial versions look like. So there are two major versions of Conda, Anaconda and Mini Conda. And the names somewhat denote exactly what we're talking about here. So Anaconda is a fairly large and complete version of what the Conda install system looks like. It comes with a lot of extra components to it that are designed specifically for people who are computationally oriented, much more closer to computational sciences than for bioinformatics or for biologists. Mini Conda, on the other hand, as the name implied, is actually a lightweight version of the more expansive Conda. And it allows us to more accurately customize the elements that we have in Mini Conda and as part of our Conda environment, and so that we can specifically get the tools that we want. And so if we were to go and click on this link here, which I've opened up here, we'll be taken to the Conda install page, which has installers for the various different operating systems out there. And we can select one of two versions in all instances. And that's the difference between this Python 3 version and this Python 2 version. And the big difference here is what you want to select the Python version that's running currently on your system. And so you might not know that. We'll talk about it in a second of how you can assess that, what version of Python you're using. Most new systems, we can reliably say, are probably using Python 3. Most old systems might still have Python 2 as their default setting. Regardless, whichever version of Miniconda you install, either the version 2.7 or 3.7, you can install the other version or create environments of the other version of Python in your Conda system. The other thing that you probably want to do, and again, this is for probably most current modern laptops and systems, is that many of them are using 64-bit systems. For myself, I'm using a 2019 MacBook Pro. If I was installing this right now, I would install this Python 3 64-bit version from the web page. And so to do this in our binder, we need to grab the install code from the Miniconda repo site, and then we have to install it ourselves using the shell script that they provide. So I'm just going to copy and paste this Ruby curl command, which downloads one file, which we can see here, which ends in .sh for being a shell script. And then what we have to do is we have to run the command to install it. And so what we're going to get is a number of elements that we have to respond to because they want us to access and use their license and agree to using their license as it currently is, just like any other terms of service. So we're going to be able to do this. To go through the argument, we can use spacebar to get all the way through. And then at the very end, it wants to know yes or no, will you accept the license? We're going to say yes. And then we're going to hit enter. And so right now it's installing in our home directory. And so you can set here a different location just by typing it in if there was somewhere particular that you wanted to install on your computer. In many instances, your home directory is totally fine for that as a location for it. So I'm going to hit enter to install it there. It's going to take a moment as we download the package and open it and put in the components, install the components correctly. We're going to type yes to initialize Miniconda. Great. And so one of the things that we need to do right now, and we're going to ask you to pay attention to this, is so currently we have our home directory, home Javian, as a standard as part of the binder environment. We currently don't have Conda working. And so the way that we do that is we actually restart our terminal using this source tilde, which is telling us looking the home directory for our bash rc content. And that will restart our shell, our terminal. And you can see there's a big difference. So now we have this word base. And so base is telling us that Conda is now active. And in this particular base environment, we can function just like we're working in Conda anywhere else, right? So what we can do is we can actually make and install programs here in base that become available to all systems under the Conda umbrella. The other thing is that we also don't need to be working in Conda all the time. A lot of the times, once you install Conda, this base comes up and you might never think about it ever again. Every so often, it might be necessary for you to not be working in Conda. And so you can just deactivate it by using Conda deactivate. And that will get rid of it's now moved to the terminal's notebook as the main place that it is. And then we can do Conda activate to turn it back on. and we get our base environment back going. And so we'll talk a little bit about how you use the base environment in a little bit. But ideally, what you want to do is you want to keep the base environment installations to the bare minimum that you need for maybe everyday bioinformatics needs. We'll talk a little bit about what those needs might look like. But the idea here is that because our main goal is creating environments that are self-contained and allow programs that can be installed that don't conflict with each other, the more that we install programs in our Conda base, the more likely we are to create elements where the Conda base has one version, we go to get another program, it needs a different version of the tool that we have, but the Conda base is the one that it's running off of, so there might be a conflict when we get to those environments. So we check, the idea is that you want to think about Conda as the overall arching structure that you're installing tools into. You only want the basic ones that you can have available in base, and then for each, either pipeline or particular tool set, you then want your own Conda environment for those particular tools, right? So you go, we'll talk about a couple of them, but you want to set up this scenario where, okay, when I run this particular tool, I move to this Conda environment, I run the tool, I leave that Conda environment, and then do something else. Workflows are obviously different if you want to stack multiple tools together, but again, that goes back to the way that Conda allows us to make reproducible content, because you can take those settings of, I had these 5 tools installed in this environment, and export them exactly the way that you had them and allow people to use that again in the future. All right, so let's go over a couple ways. I'm going to clear my screen so we can start at the top. Let's go talk about how we create a Conda environment, initialize it, and how do we start installing programs as part of it. So to create a new environment, we're going to do Conda create -n new -environment. And so the breakdown of what we're writing here is we're calling Conda, we're calling its subcommand create. -n is the abbreviation, the flag that we use for the name, and then we're giving it the name new environment. So then we hit enter. It's going to ask us if this is what we want, right? So right now we're not really doing anything complex. All we're doing is we're taking our base version and creating an exact replica of that in an environment called new environment. So we're just going to hit yes on that, and it generates pretty quickly. You'll notice that Conda gives you instructions on how to start and activate your environments, as does our tutorial from Mike. And so what we can do to enter this environment is we can do Conda activate. So again, what we're doing is just running Conda with the subcommand activate, and then we give it the name of the environment that we want to work in. So now you can see that base has changed to new environment. And so this is where we'll know what environment we're working in and be able to keep track of as we're going forward. And so at any point in time, we can use Conda environment list to look at which environments we have installed. And then an asterisk will denote which environment we're currently part of. And so at any point in time, as I mentioned before, where we get out of base, we can also use Conda deactivate to get out of the environment that we're working in and return back to the base setting. Okay, so one of the things that is very useful about Conda is the ability to set the version, in this case, of Python that we're using and creating an environment around. So our default setting, as you can see with this mini Conda 3, is that the environments that we're working in and create use Python as the I use Python 3 as the base version of Python that we work with. There are still tools out there that actively use Python 2, and by actively I mean the sense that the tools exist, people use them regularly, and Python 2 is required. Not that Python 2 is supported anymore. At this point, Python 2 is an old version of Python that isn't supported anymore. But sometimes you come across a tool that is, again, in that kind of phase, and this is where this just really works out really well. There might be a tool where the developers created it in 2014. Everybody uses it, but it runs on Python 2. No one wants to spend the time to update it to Python 3. So then what you end up having to do is, before Conda, you would have to do all these kind of like little tricks to make it so that it's running in Python 2 and not Python 3, which your computer's running in. Conda simplifies all that, so you can just say, okay, this old tool that nobody's maintaining but still has ability to be installed, I can install that with Conda, and now I can work in an environment that runs without any errors for that particular tool. Okay, so in this situation, what we're gonna do is we're gonna do Conda create, as we did above. We're gonna give our new environment a name with the -n. In this case, we're gonna call it Python version 2.7. And so here, what we've did, that is the name that we've given our environment going forward. But now what we need to do is we need to set actually literally what version of Python we want. And so we do that by typing Python equals 2.7. And now when we press enter, it's going to come up with our package listing, and it's going to ask us, do we want to install? And what it's going to do is it's going to give us a number of other components that will need to be installed to make sure that that version of Python is working, right? So this looks very different than the last version of it that we had access to, or the new environment that we created. And that's because it's installing all the other components that are necessary for Python to work and function properly. And so if we hit yes, you'll see all of these individual libraries being downloaded and installed and created in the environment for us. And so now we can take a look and see what this has done. So we can, in our base Conda, we can run something like this, where we run Python -- version. And as I mentioned before, this is how you would determine on your computer what version of Python you're running. And if I hit enter, it says in the binder, in this terminal, we're running Python 3.76. And so we can go to Conda activate. And the first place we're going to stop is our new environment. And if we go there and we type Python -- version, it also says 3.76. And that's because our new environment is just a copy, a place very similar to our base environment of Conda, where we can install things and doesn't have any extra components to it. So if we do Conda activate and move over to our Python version like this. Now we're in our Python version 2.7. Now when we do Python -- version, we get a different version of Python that's installed, and it tells us where it's from, which is the Anaconda version of this. So again, pretty useful if we come across a tool that is older and requires a different version of Python to work and function. All right, so what we want to do is we want to talk about how we remove, put a Conda in there, how we remove environments that we don't want to work in anymore, that no longer are required for what we're doing. And that's pretty easy. We're going to use a Conda remove command. And so what we do is we do Conda sub. So we're working with the environments that are part of our Conda install, which is what the environment flag here represents. We're going to say remove, and we're going to tell it the name of the environment that we wanted to remove, which is our Python version 2.7. And that moves not only the environment, but all the packages that were installed as part of that environment. So the next element that we really want to talk about is how we find the packages that are of Conda available and how we install them. And so there's a couple things that we need to discuss here. The first one is that there are many channels. And so you can think of these somewhat as like libraries or stores that you can go to where certain Conda available installs are stored that are kind of related to each other. And so one of the ones that we'll talk about pretty extensively is Bioconda, which is where people go when they have a tool that's for biology. They'll go and they'll put it specifically in that library along with all other Bioconda related tools, right? And so one of the things that you need to know is that there's no requirement for a tool to be Conda installable. It's something that a developer actively has to do. And so doing it and setting it up and putting it into one of those libraries where people can install it from takes some time. And a lot of the developers nowadays might do that. Sometimes what happens is that somebody else will take a tool that is publicly available and package it in Conda for the developer. So you might get this element where like an instance of a version of a tool is installable from Conda. It might not be a new version, it might be an old version. You might be like, well, why can't I get the new version of it? And the reason is because either developers haven't done it or somebody hasn't taken the time to package it in the new version in Conda and installed it or put it into a library for you to get. And so there's a couple, those kind of caveats are really the only caveats when it comes to what can I install in Conda and how do I get access to them. And it really comes down to who has the time and who has the incentive to put something into a package to make it easy for people to get access to. And sometimes it's developers and sometimes it's the community. So what we're going to do is we're going to install a tool. And what we're going to do that is we're going to do that in our new environment. So we're going to Conda activate new environment. And what we're going to try and do is we're going to try and install the Prodigal, which is a tool for predicting open reading frames and proteins for microorganisms. And so we can check to see if Prodigal is installed, which it won't be by doing this. And it says Prodigal is not found because we haven't done anything about that. And so one of the easiest ways to figure out what is available for Conda install is a simple Google search. And so what we would do, and what I would normally do, is I would do Conda install Prodigal and look for the output. And normally it's a pretty early hit up here. And you can click on this and it just tells you, right? So in our Anaconda library, it's in it's a library called Bioconda, and that we can install Prodigal. And it gives you just a line of the code for what you can install it from. Both the specific, the more generic library, and then information about the user's particular subsection of Bioconda that it was installed by or who. And so one of the things to take away from this is that if we were to go to just the regular Prodigal GitHub page here, what you'll notice is, again, as I mentioned, is that the people who maintain and or created Prodigal actually aren't the ones who are maintaining it in Bioconda. There's no information about installing in Bioconda. It has its old, or not old, but it's install from make version, which is what you would normally do if you were trying to install this from source and wanted to install it in directly onto your system. Right, so the mini Conda version of Prodigal has been submitted and is maintained by other people in the community. So the install command that we saw there told us to look at the channel, which is s-c Bioconda. So it's a tool that somebody has particularly put in a channel that we're calling Bioconda that it has universally contains a lot of tools that are related to biology. So we can do Conda install -c. Bioconda is the name of the channel, and then Prodigal, which is our tool that we're targeting. And again, so what it's going to do is it's going to collect the packages that it needs to install. It's going to tell us what it needs to install if it's not currently present. If we hit yes, it'll install all those components and then allow us to access Prodigal. So now when we do Prodigal-V, instead of giving us an error, it tells us what version of Prodigal we're running. And so the thing to remember is that this is only happening inside the current environment we're working in. So it's only happening in new environment. If we do Conda deactivate and move back to our base environment, now when we run Prodigal-V, there's no version of Prodigal available for us. And that's just how this is working, right? The Conda environments are separate from each other so that when tools are installed in one, they're not available in others. And so we can do things like uninstall tools that we don't want. So if we have a Conda environment that we've been working in and we realize that we're not using the tool anymore, but we still want to keep using the other tools in the environment, we can do Conda uninstall Prodigal here. And that will take away all the packages that are going to be removed. And so now these are all, instead of being installed, are removed. And now when we run Prodigal-V, we get that Prodigal isn't present anymore. And so we can also do things on our command line where we can search the various channels for programs that we might be looking for. And so a lot of times we can use just the base name of the program that we're looking for. So in this case, Prodigal. Sometimes you'll find programs that have their base name plus some extra information to denote the version or how it was uploaded into Conda. So it's not always a one-to-one setup. And so that's why the Google search works really well. But we can do a Conda search-c. So we're searching in the channel Bioconda for Prodigal. And what it's going to show us is that there's actually 2 versions of Prodigal available in Bioconda. it's going to take a second to search for the channel. And the reason for that is that you have an original version that was made available, and then a new version, a newer version that is now available. So we have that version 2.6.2 and then 2.6.3. And then there are a couple different elements here that are referring to the build. And so these are just other versions of Conda that have been installed into other instances of people loading it into Conda. So it's not necessary to know exactly what those builds are doing, just that multiple people have loaded this into the Conda library to allow people to get access to it. And so the version that we had installed previously was Prodigal 2.6.3. But if we wanted to, like Python, we could force it to install a version of Prodigal that isn't the most current up-to-date version of Prodigal. So we can do that. It uses the same, a similar setup as when we were installing our Python version 2.7, which is where we say Prodigal, and then we put an equal sign, and then explicitly tell it which version we want to download. And so now it's going to look for, instead of downloading 2.6.3, which is the most up-to-date version, we can download the slightly older version and get access to that. And so this might be useful, again, for particular tools from a particular time point where the thing that they're operating on works well for what it is, but then maybe as time goes on, elements of the tool are developed and that breaks based off of the version of the install that's present there. And so things that come to mind for this would be something like if you're working with, if you're using Python to make figures, there's a library called Seaborn, and Seaborn is still in development, so it continually adds new versions to it. And sometimes the new versions will take something that didn't work and make it work, or vice versa, based off of what's installed in your environment, right? So you might have a version that requires another program that's version 1, and then the new version of Seaborn might then require version 2, but if you have version 1 installed, now all of a sudden it doesn't work. And so being able to get back to the older version of Seaborn to work on the system that you have is always a valuable thing to be able to do. So we should talk about these channels a little bit more, because Bioconda is not the only one that exists. And there are several other channels that Conda tools can be pulled from Conda libraries. And so in the Bioconda documentation, they say what we need to do is actually prioritize which libraries we're looking at if we're not sure where our tool is stored, right? If we don't do a Google search, if we don't do a Bioconda search, there's an order that we can put in where we say, first look in this library, then look in this library, and then look in this library for the tool that I want to install. And so the way we do that is by setting multiple channel flags. And so we can do conda install -c, which is conda forge, and say conda forge, which is the main conda library, which contains all elements or a lot of the conda installed tools beyond biology. Bioconda is our next channel that we're going to install, and then defaults, which covers a lot of other kind of smaller channels that are part of the Conda library system. And then we're just going to type in Prodigal. And it's going to, again, build our search and then return the elements that we need to install to install this. And so this particular order isn't random. It's an order that has been determined not just from the Bioconda documentation, but overall from the Conda folks who manage Conda. And this order is something that we want to always do in this sequence. We want to start with searching in Conda Forge, followed by Bioconda, followed by defaults. And so we can do this by setting this explicitly when we do our installs by saying first search this channel, then just this channel, or we can modify our configuration so that these are channels that are searched in by default. And so the way we do that is by permanently modifying our config setup for configuration setup for Conda. And the way we want to do that is in reverse order from the priority for which we want them to be searched. So we'll have it search defaults last, so it's the first one that we add, Bioconda second, so it's the second one that we add, and then Conda Forge first, and that'll be the last one we add. So we can do Conda config -- add, channels explicitly, and we're going to say defaults. And so we now moved it to the top, right? Because it was already part of our setup. And then we can add if we just hit up there and just change the last one to Bioconda. And so now this is now been supplants default as the first place that we look. And then we want to make sure that the first place we actually look is Conda Forge. And now we can do that last. And so that's going to move it up. So now our channels, which we can look at here, have this order of low priority to high priority of defaults, Bioconda, and then Conda Forge. And so we can now explicitly install tools from Conda, especially Bioconda, because that's the one of the libraries that we included here, without having to explicitly list the library that the channel that we're trying to pull it down from. So here we can hit Conda install. There you go. And so now it's Conda, or Protocol has now been installed. And we can do that by checking -v, and there it is, our version 2.63. So we're going to talk about two more things before we finish this tutorial for today. The first thing that we're going to talk about is the types of tools that you might want to have installed in your base environment. So in this particular instance, we're going to go Conda activate base. And so again, these are tools that you want to install that are everyday elements that you might be working with, right? So the example that we're going to use is a tool created by Dr. Mike Lee that he has called BIT, which is short for Bioinformatics Tools. And it's a number of commands that he created that are things that he does on a regular basis and allows him really quick access to some of the elements that he works with to assess sequences and biological data regularly on a daily basis. And so the way we do that is we're actually going to, very similarly, we're going to say Conda install. We're going to use this -y flag, which is just an automatic way. So instead of having to hit Y enter to install a tool like up in here, we're just saying explicitly, yes, we're saying yes. Whatever tools that you need to install for this, just say yes. And then you see that we're searching channels explicitly. We're searching Conda Forge, Bioconda, defaults. And then there's a new channel here called AstroBio Mike, which is the channel, Mike Lee's personal Conda channel that he uses and pushes his tools to directly. So publicly available for other people, but something that you would have to look for and know exists because it's not part of it's not in the Conda channel as its default home for being stored. So we can do Conda install -y-c, Conda Forge. And again, so we don't actually have to explicitly be writing these right now, or we do because we didn't, we do because we set our channel variables configuration in our new environment and we're now working in base. So to correctly do this, we want to make sure that we cover all the channels that are available. And then our last channel, which is AstroBio Mike, and then the tool bit that we're looking for. And so we knew that this was in channel AstroBio Mike. So we could have excluded channel Conda Forge, Bioconda, and defaults because we knew exactly what channel it was. But if this was a tool that we weren't sure of, but we had an idea that it was potentially in one of these channels, we would be able to explicitly call each one and do a quick search in each of those channels to look for the tool that we're looking to install. So that install takes a couple minutes. And so let's take a look back at what we did. So one of the things that you might have noticed, it took a little while for the libraries that we wanted to install to be identified. And that's because we sequentially went through all of the channels that we listed before we got to AstroBio Mike. So that sometimes takes a little bit of time for Conda to figure out what packages need to be installed along with the tool that we're asking for. And then you can see that there is actually a fairly large number of tools that are built in on this. And so, you know, as I was explaining, the tool bit that Mike created is what he considers his base elements that he needs regularly to access his data his biological data. And as you can see, it's not just, you know, a couple handful of tools. It actually covers a pretty large swath of tools and versions of things that are very particular to what he wants running for his bit tool setup. And so, you know, this goes all the way back to why Conda is great, is that these tools might be one particular version that runs very well for bit. And then if we move into another tool set, you know, if we're looking here, something like SciPy version 141, you know, that might be the most current version of SciPy. It might be a version that only works with bit and is a couple versions out of date. And so when we move into working with another tool and we want to use SciPy 144, in that instance, bit still works in base. And then in our new environment, whatever we're installing now works well with the SciPy, the most current version of SciPy, or the version of SciPy that it explicitly needs to run. And so we can check to see how it worked out. We can use bit summarize assembly for this random assembly file that is stored here. And we can get some information back about how many contigs there are, length of information. And if we wanted to see what other tools were available from the bit package, if we do bit dash and then hit tab twice, we then get a list of all of the tools that these packages and code that Mike has written all work together to get a particular output. And so then the last thing that we want to talk about today is how we take all of what those little pieces are. We create an environment, we go into the environment, we download some tool. We can actually do all of that in a single step when we create an environment by explicitly telling it what tool we want to work with. And so in this particular example, we're going to use a program called G2Tree, which creates phylogenetic trees based off of concatenated marker sequences. And so we can do that by using Conda, the subcommand create. We're going to say -y, just say yes, install the packages. We're going to give it the name G2Tree. So that's the name of the environment we're going to work in. We're going to explicitly list out the channels that we want it to work with. Conda Forge, BioConda, in this particular case, also AstroBio Mike. So you can see we left off defaults. Again, this is one of those tools that we know is available through the Mike channel, the AstroBio Mike channel. Here, we're going to explicitly say what tool we want. And so if we wanted to, we could then also install multiple tools, right? So it could be G2Tree. If G2Tree also required Prodigal, we could put Prodigal here. If it also required bit, we could put bit here. And then we can explicitly say what type of Python, right? So we know that by default, it's the type, the version of Python that's in the base environment. But in this case, we want it specifically to be Python 3.7. And so we can write that so that, like, in the future, if it goes to, you know, Python 3.9, we can say, oh no, explicitly go back and use Python 3.7. So we can hit enter on that. And so this again will search through the channels. We've told the default run yes, and then it will install and create a new environment that has G2Tree as part of it. So now that we've gone through and installed all the necessary components for G2Tree to run, we can do Conda activate G2Tree. And now you can see that we moved from our base environment to the G2Tree environment. And then we can ask things like, G2Tree, what version are you? And here it'll tell us what it is. And then we can run some of the other commands that are part of this, like G2Tree HMMs, which generates a list of the available single copy HMMs for different subgroups of bacteria and archaea. That's built into as part of the system. And so or part of the tool. And so we can leave this environment, kind of deactivate, head back to base, and then conclude with this tutorial. Thank you for tuning in. If you have any questions, please do so either in the comments of this video or in the Slack channel for BVCN. Thanks very much.